All right, so we've talked a lot about object-oriented programming. We haven't really gotten a chance to use it all that much. We're going to be using it a lot more in the coming weeks. What I'd like to talk about is kind of more of a bigger picture thing, because object-oriented programming is one of two kind of most common paradigms for how people like to think about their code. Object-oriented programming is what you find in Python for the most part. Has anyone heard of the alternative to object-oriented programming? Functional programming, yes. So JavaScript is a functional programming language. Now, you'll see a lot of think pieces on the internet and in books about why one is better than the other. And I'm going to tell you right now, most of the people who do that are kind of jerks. And honestly, it's not much. There's not really much point to the debate because they both have good reasons to be used in for different situations. So object-oriented programming is useful for anything where you have to deal with state, meaning keeping track of how things are. Because the whole point of object-oriented programming is we create these elaborate data structures with built-in behavior to manipulate data. Functional programming is all about functions as opposed to objects. It's a lot faster, and the way you can use functions is more flexible. So functional programming is kind of having a moment in the sun right now, but they both have good reasons. And kind of the end result of what we're going to be doing in this program, and for a lot of coding things, is going to be a combination of both. On the front end, you'll see a lot of functional programming with JavaScript frameworks, and on the back end, you'll see a lot of object-oriented programming. So I'd like to talk to you kind of about the big differences between each. So first I'm going to talk a bit about functional programming. So functional programming, as you can probably guess, is all about those functions. And functions in JavaScript, one of the cool things about them is you can just kind of pass them along as variables to other things. So for example, if I say, let add up equal, and I'm going to make a function that takes in A and B, and it's just going to return A plus B. So add up, if I just, console.log add up, I can know how to print type, there we go. So I do node JavaScript, functional programming. I get a function called add up. And I can, assign that to other variables. I could say, why can't I hit the U key? That's very weird. All right, console.log. I do that now. So it's still the same function. We just passed it to a different variable. And you'll see this most often in things like, well, what's called callback functions, which we haven't dealt with much so far. Eventually, you're going to be dealing with callbacks all the time, because some JavaScript functions take other functions as an argument. So my favorite example is .map. So I could say, let array equals 1, 2, 3, 4, 5, 6. Let's say I want to multiply every number in that array by 2. We could loop through the array, say, for I equals 0, I is less than array.length, I plus plus, and then say array I equals array I times 2. That's one way to do it, right? But there's a simpler way. There's a function that JavaScript has called .map. And what .map does is it allows us to manipulate an array in one line. So we can call it array.map on this map thing. And map takes a callback function as an argument. And that callback function says, okay, what do you want me to do to each element in this array? So I could write an anonymous array that says, all right, takes x as an argument and just says, and returns x times 2. So this is a very bare bones fat arrow function. If you put it on one line, you don't need the brackets. So if I run this code again, this anonymous function here, as our argument for .map, has been called on everything in this array and returned in a new array. And I could also create a different, just name that function. I could say, you know, let doubler equal x, return, and then just call doubler here. It comes to be the same thing. Oh wait, I just called log doubler, not array.map doubler. Okay.
Is map constructive or a destructive method?
Good question. We can test that, right? So we can say console.log the return value of array.map doubler and console.log array. So either if it's constructive, we'll get 2 different arrays. If it's destructive, we'll see the same array twice. So map is a constructive method, means it returns something else. And as a point of fact, and Tom touched on this yesterday, all methods in functional programming, if they're done right, are what we call pure methods. Who remembers what Tom said about pure methods yesterday?
So you do not modify the whatever you pass.
Exactly. So when a pure method takes in x and returns y without altering x in any way. So .map is a pure function. It takes in an array and returns a different array of the same size. And there's a few other things that define a pure function. So besides not altering the original input, another thing that a pure function mustn't do, it can't have side effects. That's another thing. So if we take our doubler function, for example, doubler equals x return x times 2, we couldn't do something like this. Like we shouldn't have an array called doubles numbers and say, you know, double numbers dot push x times 2. That's a no-no for functional programming because, there we go. Because in this case, what we're doing is we're changing something that's outside of the scope of the function. The function's job is to return a doubled number. It's not supposed to edit an existing array or any other thing like that. It only has one job. And then another thing is, so that's one thing. You can't have side effects. Let's see here. There's something else I'm missing now. Anyone know anything else about pure functions? They also have predictable output. So a pure function should not be random. A pure function should, like if I put in doubler, if I put in 2, I should always get 4, no matter what. So obviously some functions that are designed to do random things aren't going to be pure, and that's okay.
Oh, there's a word for this, right? Deterministic.
You may be right. I'm not actually sure.
I think I've read that.
One example of something.
Deterministic? Yeah. So in any case, this function right here, doubler, is a pure function. Returns x times 2. It doesn't say, you know, x equals x times 2, return x. Actually, I don't know if that would actually change the original one or not, but we don't want to go down that road anyway. All right, so we'll get we'll see more of functional programming later on in the program when we're dealing with front-end programming and frameworks like React. But does anyone have any questions about functional programming right now and pure functions and why they exist? Okay. So I'm going to move on, talk about, so that's functional programming. Okay, now let's review object-oriented programming. So you may remember this from last time. We talked about it. So we have a dog class in this case. So what's the advantage of making a dog class? What does that allow us to do vis-a-vis dogs?
It allows us to store variables in the class and allows us to store attributes in the class.
Like you can set it up in the Slack. It gives us a blueprint so we can keep reusing the same thing over and over to create more instances.
Yeah, exactly. So what they're saying was that using a class like this allows us to create a reusable data structure. The dog class in this particular case serves as a blueprint for us to create these dog objects. We can make more and more dog objects to keep track of every dog in our system. For some reason, we've got a bunch of dogs. And so it focuses more on keeping track of state. So functional programming, we don't care about state. Object-oriented programming is all about state, making sure that we can preserve it in such a way that we can access everything and it's all organized in a very easy to do way. So I'm gonna comment this runner code out. Let's make another class. Just review it. So I'm gonna make a class called account, like for say a social media account. So I could, I'm gonna have init here. And what kind of things should an account keep track of? Yeah, username. And a password. Obviously, in a real data structure, you don't want to keep just an unencrypted password into your account, but that's a problem for another day. Sorry? Yeah, you could say account number. We could leave it at that for now. Oh. I was going to say this is more like a social media account, but
okay.
Maybe, actually, it may be more descriptive. We call it user. And so maybe instead of account number, in this case, we can have like email address. So we can say, have the self.username equals username, self.password equals password, self.email equals. So this way, whenever we want to create a new account, all we have to do is just say, equals Noah equals user. My very secure password. So now I have this no object, and I can just keep on making user objects. And I can manipulate them in ways, I can manipulate them directly. So I could say, Noah dot, want to update my password to something more secure. There we go. And I can also, create methods to update this so I don't have to write my own code every single time. I could just do it every time. So I could make a method to say something like, I don't know, what's a good thing you might want to be able to do as a user?
Change your password.
Yeah, so update password. And okay, so what's an advantage of making a method to do this rather than just doing what I did here?
You can implement checks for errors or formatting or requirements, stuff like that.
Yeah, Exactly. So I could, say something like, so I could take new password as an argument.
This is somewhere you can use regex to make certain requirements, right?
Exactly. So this would be a great place to use regex to, validate that it's a good email, or a good password. So I could say something like, if, len of new password is less than 6, and then we could also have, let's see, I'm trying to think of we could do, well, we don't have to get super into the regex right now unless you guys want to. Do you want to? Yeah. I'm just going to stick with the length of the new password is less than 6. You could say something like, return none, else self.password equals new password. So now if I try to say noah.update password with oops, wrong thing. Password must be longer than 5 characters. Let's see. All right, so that's all I really had to say. Just a quick review of object-oriented programming as we move forward. In the coming weeks, we're going to be doing. We'll be moving on to using frameworks like Django, which is going to be kind of putting a much heavier emphasis on object-oriented programming. So even though for a lot of the challenges we've been doing, it hasn't really necessarily been necessary unless we've told you so. Just keep object-oriented programming in mind as we move forward, because it's going to save your lives, essentially. Does anyone have any questions about object-oriented programming, things that have been bugging them for a while, or things that have been confusing them about object-oriented programming up until this point? Remote, anybody have any questions about object-oriented programming that you've been too afraid to ask until now?
Are we just gonna, for now, worry about object-oriented programming in Python, or are we gonna go over kind of how it looks in JavaScript, or is that save for a later date?
Good question.
Well, JavaScript's a functional programming. They do have the class keyword, and it kind of operates the same as an object, but you really don't see that until you get into React, which is like, I don't even know, week 8.
Yeah.
Something like that.
So, yeah. So we will be talking about object-oriented JavaScript at some point when we get to React, but for now, you only have to worry about functional JavaScript. And again, even though JavaScript can do object-oriented stuff, it's really a functional language. I think I remember I saw like a comic somebody made of if different coding languages were types of music, and JavaScript was a one-man band because it can do everything, but it doesn't necessarily mean it should do everything.
Mm-hmm. GP scroll down from line 59.
Yeah, exactly.
So yeah, you can assume that we're going to be doing object-oriented programming in Python. So once we get into React, like classes will make more sense, or it'll make React make more sense if you didn't know object-oriented programming.
All right. So last thing I'd like to talk about is libraries, just a little bit. So whenever we do something to import a library, like, say importing the regex library, for example. So whenever we're doing that, all we're really doing, it's Python essentially copying and pasting all of the methods in this regex folder into our document. so that we can use them. It's all just kind of held in that one line. So that's really all that it is happens when you import a library. You are literally just copying and pasting somebody else's code and then using it. It's not magic. You could go to the source code of a library, whether it's an internal Python library or someone that somebody made, and just copy everything from the GitHub onto your page, technically, but there's usually too much to actually do that. But in theory, that is really what's happening. So that's all importing a library does. Whenever we want to install a new library, and I encourage you to all kind of look through Python's libraries and JavaScript's libraries, see if you can find one that does something cool, because you never know. There's different ways to install it. With Python, there's two most common installers. One is pip. Pip is the one we've been using. There's also one called Anaconda. Generally speaking, pip is usually the installer for when we talk about web development, when Anaconda is mostly the installer for things like data science and analytics. So you'll use both depending on what you're working on. So when we work with things like pandas, we'll mostly be using Anaconda, but while we're working with regular vanilla Python and Django, we'll be using pip. So I'm going to show you a list of, in the GitHub curriculum, there's a list of very useful Python libraries. 20 Python libraries you can't live without. We won't go into these in details right away. At the bottom of the list, we have IPython, the one we were using earlier. So IPython is huge. It's got all sorts of cool capabilities, not just embed. But there's also things like requests, which allow us to contact websites, make HTTP requests. There's web scraping. There's WXPython, which allows you to make a graphical user interface just using Python, it's a lot better than Python's built-in library for that, which is called tkinter. Definitely use WXPython, not tkinter. Tkinter is awful. If you ever want to get information from a website, you can use Beautiful Soup. Beautiful Soup is a godsend. NumPy and SciPy, I think we're probably going to be doing that when we talk about data science. Pygame, if you ever want to try using Python to develop games, Pygame has built-in 2D game development. Something I'll pick, I haven't never used this one, but I've seen it work. Like Piglet, somebody actually made a Python port of Minecraft using this thing. Pretty awesome. Has anyone ever used a Raspberry Pi before? I'm just curious. Yeah, so Raspberry Pi actually ships with Pygame and the Python port of Minecraft with it often. Yeah. So this link here is great for if you ever want to try Python, but if you just want to Google for cool Python libraries, all sorts of crazy stuff will happen. So if you wanted to say, they have all this stuff, like let's say I'm going to a Python library for just changing the color of output, like color output command line. I bet there's a library for that. Aha, COLR, PyPy. Let's see what it says. A Python module for using terminal colors. It contains a simple color function that accepts style and color names. Outputs a string with escape codes. So installation, they give us the installation, so we can just do pip install color. That look pretty simple. We could say from color, import color, and then we can actually do something. So we could say, then down here we could say, so we want to print color. So we'll add update password, and if I wanted to make this red to show that it was bad, I would just do 4 equals red, style equals bright. So now if I run this code again, uh-oh. Ah, I see what happened. Okay, I guess it didn't work. All right, so maybe this example is bad. I'm not really sure what went wrong here. Because it didn't break, it just didn't work. Maybe if I just do a string instead of this. There we go. So
What you have before was it?
it was the output of this. So maybe I would have to do that in the function, saying print.
Yeah.
What was it? Style equals bright. So just go. Try it again. Password must be longer than 5 characters. Yep. So there is, generally speaking, there's a library for just about anything, both in Python and JavaScript. The ones we're going to be making the most use of in Python, like I said, we're going to be using NumPy a lot when we get to data science, along with pandas. And then we're also going to be using Django. So Django is a framework, but it's also a library. And it's essentially a huge library that we import, and it gives us a new way of organizing our code in order to create a website. So generally speaking, most Python libraries you're going to find are going to be backend libraries, things for manipulating things on the backend rather than changing things how they look on the front end. Like Django allows us to, like you can make a front end interface with Django. You can just make a vanilla Django website, but it won't be very interesting. And that's where JavaScript comes in. So just like Python, JavaScript also has a crap ton of libraries. So gonna show up. So they have a thing of popular libraries here, including a lot of them are frameworks like React, React Native, Angular and Vue are also both very popular JavaScript frameworks. But again, so you going to javascripting.com, you can find all kinds of cool stuff. So if you want to say, for example, something that makes really good forms, just click on forms. They've got all this stuff. If you want to make games, you can use Pixie.js or Phaser or any of these things. So again, if you ever just want to make sure that you want to try something new in JavaScript or just something that would make you think would make your life easier, go to javascripting.com or just do a simple Google search for a cool JavaScript library, and chances are that you're going to find something useful. The one that we're going to talk about most is React, because React is very, very powerful, very, very popular, very, very useful. Facebook is made using React, and so is Instagram. So by the end of this course, you're going to be able to make a fully interactive React website, just like Facebook is. Well, not exactly like Facebook, but you get the idea.
React was developed by Facebook.
Yeah. And for a while, they had a thing that says you couldn't use React to build things that might compete with Facebook. They've since changed that, which sucked. Yeah. And one thing I just want to caution you all about is, okay, yeah, install all the libraries you want. Not all libraries are created equal. So most of the time, if you find one, they'll have something like this where they'll say a rating, how many stars it's got, or GitHub watchers, how many times it's forked, number of contributors, stuff like that. Generally speaking, if these numbers are higher, it means it's a more established library. That means has better support and is more trustworthy and effective. So although you may find a really strange, fun library that nobody's ever heard of, the more popular a library it is, it's usually because it works. So always just keep that in mind while you're doing that. And read the docs. Usually the GitHub page will have a lot of help on that. Something in React is a little too big for that, but if you wanted to do, say, go to forums, find Parsley.js. This sounds fun. So it's got an 83% rating, not bad at all. If I go to the GitHub page, let's see what it says. So, yep, so they got requirements, questions, integrations, installation guide. So we'll mostly be using NPM for installing JavaScript libraries. And then, so they have very sparse documentation in this case. So that's probably why it's only got an 8.3 instead of like a 9.9. But generally speaking, if you can't find documentation, it's probably not a good library. So the better documented it is, the more you want to use it. Okay. What questions do you have about libraries? Is that your hand up, or you just?
Oh, no, sorry.
Okay.
Is there a list of ones that we have already installed? Like, you know how we can just import things right now?
JavaScript, they don't really have built-in libraries like
Or
Python does.
For Python, do we just go to like the website?
No, there's not like a, I
Yeah.
don't know the list that already built
Yeah.
in.
So, yeah, we go to like Python libraries. Let's see what happens.
Like,
The Python standard library.
okay.
So Python's documentation is very extensive. So they've built in stuff. And we go to data types. I bet they have something about other libraries that you can use. Oh, there's a lot here. Okay, but if I, for example, if I want, typed in Python, just RE, we've been using that. That's still included in the standard Python. It's a standard Python one. Oh, we click on modules. Aha. So this is an index of all the built-in Python modules that Python ships with. And there's probably a way to see all the external ones you've installed too, at least with ones using pip. Or at least I know the ones that Ruby does, they allow you to do that, but I don't know if pip does that. Let's find out. Pip all packages. Let's see if we can pip list. List installed packages, including editables. So this has a list of every package that I've installed using pip. Some of which I didn't even know about, but there's color, the one I installed just now. Green, IPython. I wonder if NPM has a list thing too. Well, that's not encouraging. But NPM may have a different thing for that. So I do NPM list all packages, list all global packages. Okay, this one looks good. NPM list -g. Ah. So looking globally now. Ah, okay. So there's a lot. But if you're ever not sure, if you ever want to check which ones you have, you can use the list command for both pip and NPM. And if you're ever not, I can also do something like, if you ever want to see if something's installed, you can type in which and then the name of the package. And if it's there, it'll tell you what the path is to where it's been installed. Or you can do name of the package, usually -v. Okay, maybe not that. Maybe it's a lowercase dv. Usually that'll show you the version. Okay, guess not. I don't even know what this is. docopt. The color tool requires docopt to parse command line args. Okay, so it doesn't work for color. But other things you can usually check what version you have installed by typing in the name of the package -v. Any other questions? Okay. All right, in that case, that's where we're going to end today's lecture. You have a few challenges to do. This is another one of those days when you'll be doing it first in JavaScript and then in Python, or vice versa, as long as you do both of them. Make sure that you're pseudocoding. Make sure that you are making the tests before you write the entire function. I've seen a few people writing the test afterwards. This is also going to be a paired day, so Tom's going to slack out the pairs. All right. Thank you, guys.